Spending time on rivers restores my sense of connection with the natural world. It makes me think about my place in that world and my role as a contributor. And that leads me to question how we collectively contribute to the natural world and whether we really know, well enough, the effects we're having on it. As a paddler, every trip is an expedition, a journey of discovery no matter how brief. So it was exciting to learn of an expedition to paddle the length of the Grand River, some 260 miles, and to sample the water quality along the way, from the headwaters to where the river enters Lake Michigan. When COVID entered the picture, the public part of the expedition was canceled, but the water survey was not. I reached out to Professor Peter Wampler of Grand Valley State University to see if we could bring our cameras along on the survey, and he readily invited us to join him and the team as they collected the data. We met in the parking lot at the river's headwater of Center Lake in the community of Michigan Center. As the team was preparing to start their work, Dr. Wampler shared some background about the project.
In 1990, there was a Grand River expedition, one of the every decade expeditions, to float the entire river from the headwaters to the mouth in Grand Haven. One of the original goals of the expedition was to collect data. And they went along on that expedition and collected samples at 35 different sites. At those 35 different sites, they did things like temperature and pH, other water quality measurements, so they could calculate what's called a water quality index. And that basically is like a health score for the river. And so that's what they did in 1990. And so we're going back to those same sites by vehicle at the moment so that we can collect the same data, same type of data, and directly compare it to the 1990 data.
Professor Tara Nishat brings additional expertise and insight to the survey team.
The water is all connected in a watershed, and so whatever's flowing into here, into the river, is going to affect everything downstream from here. So we really care about getting the entire watershed, and that's why we're starting here to see how things evolve as we go downstream.
We are near Center Lake, and so we're at the headwaters of the Grand River. This is where it starts. So our goal is to get a really great data set, so in 2030 they can really have a good data set to evaluate the changes over that tenure. Yeah, I'm extremely excited to be here. I mean, it's a grand project, really. We're sampling the entire river, and we're doing it in a couple days. And I'm a fluvial geomorphologist, which means I study rivers. That's what I do. That's my profession. So to be able to sample the Grand River and to do it in this way is a unique opportunity. It's something that doesn't happen all the time. So I'm really excited to see what we find, what the data tells us, and what we learn. I mean, I think we'll learn a lot in a very short time. In a couple days, we'll have a very good idea of what the heartbeat of the river is at the moment.
Before the data collection starts, the gear needs to be assembled, tested, and confirmed that it is working correctly.
So this is measuring pH, temperature, conductivity, turbidity, dissolved oxygen, and reduction oxidation potential, all kinds of stuff. So this is a really smart thing right here. And then it takes readings every 2 seconds. So we record it at each stop, and then it actually sends you an email, a PDF of your data for about 10 minutes at each site. Mm-hmm.
So it'll measure things like the clarity of the water, the amount of sediment in the water.
These are all like normal parameters you look at. If any of those are high or low, then that gives you a sign that maybe something's wrong, or just gives you a baseline. And then we collect other samples for more detailed chemistry.
And the conductivity would be a measure of essentially the salts in the water. So if you had a bunch of salt running off this parking lot, conductivity would be really high because there'd be a lot of ions and salts in the water. Looks like it's working.
Simplest measurement.
This is a float that we're going to use to simulate being out in a boat, since we're going to be doing our sampling from vehicles. So when they did the original sampling in 1990, they were probably in a kayak, and so the sampling would have been within the river itself. So we're going to float this out a little ways from the bank so that we can take our probe down a little bit away from shore and get better data.
After confirming the multi-parameter probe was working correctly, it was put to work acquiring the first official data sample of the 2020 Grand River Water Quality Survey. As the probe collected sensor data, the team set about collecting water samples for chemical analysis.
So it's really important when you collect a water sample to make sure that it's truly representative of what the time and place is where you're getting the sample. And there's lots of things that can affect chemistry, temperature, the pH, oxygen's huge. You start having all kinds of chemical reactions. So what you want to do is, if you want to truly preserve the snapshot in time of what your sample is you need to make sure that your bottles are really, really clean. And in fact, rinsing them with the sample water even beforehand ensures that what's going in the bottle is the sample water. And then of course we put them right on ice. You want to cool it right down, so any microbial activity that's going on, algae, anything like that, you want to stop it, because that's going to keep changing the chemistry of the water sample in the bottle. So you're trying to preserve that. And in fact, we'll close it up, put it in the dark too. So cold, dark, that's the key. And clean, very clean.
Another important data sample to gather is a measurement for E. coli. This sample uses a sterile bag to hold the water until it gets to the lab. The final measurement to complete the data set is a measurement for water clarity.
So this is called a Secchi tube, and it's basically a clear tube with a ruler on the end. And in the inside, at the very bottom of the tube, is a disc that has a black quadrants. And there's 2 black quadrants and 2 usually white quadrants. And so what you do is you fill this tube with water from the lake or river or whatever you're measuring, and then you look down and then you release water until you can see the disc essentially. And that would give you a measurement of the clarity of the water. So as you get like drove through Lansing, the river is brown. I mean, it looks like chocolate milk. So that's not going to be very conducive to seeing through it. Whereas here we haven't had that much input, so it's still fairly clear.
A lot of times we think that really clear water is just really pretty and that means it's healthy, but that is not always the case. Sometimes if you have a lot of invertebrates that are filter feeding, they can overeat sort of the algae supply, and that can affect the whole food chain. So there's sort of a window of what's good. You want a little bit of food in there, but not too much food. And that's really what a lot of this is looking at. Algae, and then also suspended sediments, which we're not really seeing here at all. Yeah, I'm looking down here and I'm seeing a very healthy population, lots of ducks eating food, and there's certainly algae and stuff on the rocks. But if you're in a lake that's eutrophicated, is the word, is when you have really, really big algal blooms, the ones that look all green and slimy and stuff, that's too much. And that means that stuff's dying, and the death of that algae causes the dissolved oxygen levels to drop, and then the fish don't have enough oxygen, and so it starts affecting things up the food chain. So in this case, I think this just looks like a nice, really healthy lake. We don't have the chemistry yet, but this would be it's okay to be clear and not clear. And that's the least clear answer you're ever going to get on that.
After the first sample of the survey was taken from the lake, an unexpected opportunity arrived that added a data point to the survey plan.
So this is turned into a unique opportunity because the person who operates the dam, which is the headwaters of the Grand River, happened to be here, so he was able to explain to us the history of the dam. And it was built in 1911, and it basically regulates the initiation of the Grand River.
The dam operator helped the team get access to the river close to the dam to acquire the first set of samples from the river. The plan originally called for the first samples to be acquired about a mile downstream. Taking advantage of the opportunity to get data at this location provided an unexpected discovery that underscored the importance of the survey.
So there's also an input right here from the wastewater treatment plant for the town, and so we wanted to get a sample below that so we can determine what has changed from the lake, but a significant change from the water quality in the lake versus here. So an unscheduled opportunity, yeah, and then this is something that happens in the field all the time, and when it happens, it's great because you get a unique opportunity and unique. We wouldn't have known this is here. We wouldn't have access behind the gate. It was a great opportunity, and we appreciate Joe helping us get in here and providing the opportunity.
With the beginning of the survey data collection, the first thing the team discovers is that the river literally starts with a discharge from a wastewater treatment facility. This gets to the heart of why water quality surveys are important. How are things we allow into the river affecting the water quality? Join us for the next episodes of River Stories as we continue this data gathering expedition to address that question. If you like River Stories, be sure to subscribe to the channel and share the link with friends and colleagues.